Good morning. Today I'm going to discuss some example problems related to simple harmonic motion. Problem number 1. A mass of 150 grams is raised through 1 millimeter. Determine its gain in potential energy. Here we use delta potential energy equals m times g times h. It is equal to 150 times 10 to the minus 3 kilograms times the g is 9.81 times h is 1 millimeter. Then the gain in potential energy is 1.5 times 10 to the minus 3 joules in two significant figures. Question B. A simple pendulum consists of a bob of mass 150 grams attached to a light inextensible string. This figure shows the variation of the potential energy Vp with the horizontal displacement x of the bob. The bob is displaced sideways while keeping the string taut until its center of mass is raised vertically through 1 millimeter and then released. We would like to sketch labeled graphs to show the variation with x of the total energy and the kinetic energy. And of course, you've done this before. This is the variation of kinetic energy, this one. And this one is the variation of total energy. It must be at 15 times 10 to the minus 4 joules because the gain in potential energy is 1.5 times 10 to the minus 3 joules. It is equal to 15 times 10 to the minus 4 joules. So this is the graph. And then the next question, by referring to figure 5.1 or otherwise, state the amplitude of oscillation of the pendulum. We have to see now at the energy of 15 times 10 to the minus 4 joules, what is the displacement? That will be the maximum displacement or the amplitude, because this will be the maximum potential energy, 15 times 10 to the minus 4 joules. So the amplitude will be at x equals 40 millimeters when the energy is 15 times 10 to the minus 4 joules. Next question, number 2. Figure 6.1 illustrates a metal tube closed at one end, floating upright in water. The tube has a constant cross-section of area 1.3 times 10 to the minus 3 meter squared. Now we would like to find the force acting on the base of the tube due to the pressure of the water. Given at depth h, the pressure due to the water is 9.8 times 10 to the 3 h. P is in pascals, h is in meters, and the base is 5.5 centimeters below the surface of water. So if we want to find the force acting, remember this equation, pressure is equal to F over A. So F is equal to pressure multiplied by A, and that pressure is 9.8 times 10 to the 3 times H. We multiply by the area. The H here is this 5.5 centimeter or 0.055 meters. And the area is this one, 1.3 times 10 to the minus 3 meter squared. So we find F 0.7007 or 0.70 newtons in two significant figures. And then we would like to write down the direction of the force determined in 1. Of course, the direction of the force will be upwards. And then we want to write down the weight of the tube. We know that this metal tube is floating on water, and when it floats, then the weight should be equal to the upthrust, so that it will be equal to 0.70 newtons. The next question now, the tube is pushed a short distance vertically into the water and then released. What will happen? Then it will move up and down on water. Yeah, so it will oscillate, and the variation with time t of the depth h of the tube space is shown in this figure. Now, from this figure, we would like to determine the amplitude of the oscillations of the tube. Look at this graph. This is a sinusoidal graph, and then you can see the maximum position and the minimum position. So when we want to determine the amplitude, it will be that maximum position h, which is 7 centimeters, minus 4 centimeters, the minimum position, divided by 2. Because amplitude is the distance from the equilibrium position to the maximum height. The second question is to find the frequency of the oscillation. To find the frequency, we should see x-axis. X-axis shows us the time needed to oscillate, and we can find period if we know the time needed to do one oscillation. One oscillation is from this maximum position to the adjacent maximum position, and that will be 0.3 second. So the period is 0.3 second. That's why the frequency is 1 over period, or 3.33 hertz. From your answers to 1 and 2, find the maximum speed of the tube. Before we find the maximum speed, I want you to see the equation of displacement. Displacement is the amplitude x0 times the cosine of omega t. And v is the first derivation of x. So if we derive these ones, then we'll find minus omega x0 times the sine of omega t. And if the sine omega t is equal to 1, that will give the maximum value of v. So omega times x0 will be the magnitude of the Vmax. So Vmax will be equal to omega times the amplitude, or x0. X0 is the initial displacement, or equal the amplitude. Then acceleration is the first derivation of v, dv dt. So we would like to derive this once again. Then we'll get minus omega squared times x0 times the cosine of omega t. You can see that x0 times cosine of omega t is equal to this x displacement. So acceleration is equal to minus omega squared times x. That's why the direction will always be opposing the direction of displacement, and the magnitude is proportional to the magnitude of the displacement. Now we'll go back to the Vmax. Vmax is equal to omega times x0. Omega itself is 2 pi f, so we can find the value of Vmax if we know the frequency, which we had calculated, 3.33, and x0 is the amplitude, which is 0.015 meters. So we'll get Vmax, which is equal to 0.31 meter per second. Question 3. A particle P is attached to the cone of a loudspeaker. The variation of its acceleration A of it with its displacement x is shown in this figure. Yeah. Now, by referring to this figure, you have to give an explanation why the motion of P is simple harmonic. Let's see this graph. This is a straight line graph with a negative gradient passing through the origin. So from here, we can see that acceleration is proportional to minus x, minus displacement. This is the characteristic of a simple harmonic motion. So we can say that this motion is simple harmonic motion. The second question is show that P is oscillating with a frequency of 460 Hertz. To find the frequency of oscillation, here we can see the omega. We can find the omega. If this is an acceleration against x graph, then we can see that this omega squared is equal to the gradient. this omega squared is equal to the gradient, because the gradient will be negative, and this is A against X. It is going through the origin. So this acts as the y-axis, this acts as the y-axis. So this is the gradient. So we can say that omega squared is the gradient of the graph, and we can find the gradient by looking at the numbers. This is 3,400, this is minus 3,400, and this is 0.4, this is minus 0.4, multiplied by 10 to the power of minus 3, because it is in millimeters. Then the gradient of the graph, or omega squared, is equal to 8.5 times 10 to the 6. So omega is equal to the square root of that, which is equal to 2,915 radian per second, and omega is 2 pi f, so f is equal to omega over 2 pi. That's why frequency can be calculated as 460 hertz. The next question is about the maximum kinetic energy. The line has a gradient of magnitude g, which we have calculated before. Given that P has mass m and is oscillating with amplitude a, show that its maximum kinetic energy E max is given by this equation. We can say that yes, this gradient is equal to omega squared, and V max is omega times x0, as I have discussed before, and E is equal to a half mv squared. If we want to find maximum kinetic energy, then V should be maximum 2. So we can substitute this V max by using this omega times x0. So E max is equal to a half m times omega squared x0 squared. X0 is the amplitude. Here we should use this amplitude a. So this is equal to a half m, omega squared is g, times a squared. And last question, find the maximum kinetic energy for P of mass 2.5 times 10 to the minus 3 kilograms. We'll just have to use this equation. Kinetic energy maximum is equal to a half mga squared. M is given, g is what we calculated, the gradient, and a, the amplitude, is 0.4 times 10 to the minus 3. We can see it in the graph. Here it is, 0.4 times 10 to the minus 3. So that is the value of the amplitude. So E max is equal to 1.7 times 10 to the minus 3 joules. Okay, that's all. If you have any questions, you can contact me, of course, in this number. Thank you. I hope this video is useful.